Hi, as you just heard, I'm Dave Hoepelman, a Scala developer at CodeStar. And I've been working with reactive programming for a while now, about 3 years. First studied under Erik Meijer at TU Delft. And reactive programming is really up and coming. I mean, the previous speaker talked about it, the next speaker will talk about it. And what I wanted to do with you today is take you through a few topics that you will encounter when you do reactive programming, specifically with RX. So I won't tell you why you should use reactive programming. I will tell you how to solve problems with reactive programming. So, in the next JDK, an interface for reactive programming will be put in. It's called Reactive Streams, and there's several different kinds of streaming libraries that all use their own names for different concepts. So unfortunately, you'll have to do the translation of this yourself. I'll mostly be using the RX Java and RX Scala names, observable and observer. But the concepts here are useful for all of these libraries, and well, Reactor was very heavily influenced by RX Java, so you can almost write this code, translate this code one-to-one. So I'll be using the word observable, which is simply something you can subscribe to as an observer, which will then start sending you events. So in the interface for observer has 3 options. You can get 0 or more events, true or next, and you can finish with either on error or on complete. So this is all fine and dandy, but as soon as you start building these beautiful reactive programs, you start getting into a very common problem, which is called backpressure. For example, on my right side, your left side, you have an observable which ticks every 100 milliseconds, and on your right side, you have an observer that listens to that and does some computation every time that happens. And that computation takes about 200 to 400 milliseconds. So what will happen? Well, it's something similar to this. The observer just can't keep up with this. So to remedy this, Reactive Streams introduced a concept called backpressure. And if you don't have it, then you'll see something like this. So you'll start getting events, and at some point, the observer can't keep up, and it will just throw an exception telling you, I don't have a clue what to do with all this data. Luckily, we can remedy that. Backpressure is in Reactive Streams implemented as before the observable can send data to the observer, first the observer has to request a certain amount of items to the observable. So for example, the observer can say, oh, I can now handle 100 items. You can send me up to 100 items. And at that point, the observable will start sending at most 100 items. And this is mandatory in a Reactive Streams publisher. You can also introduce the backpressure into observables yourself. There's 3 ways for that. The first thing is you can just buffer things. So whenever you have an observable that produces a lot of data and an observer that can't keep up, if you put a buffer in between there, events will just pile up in there. Of course, you can run out of memory if you do this, so be careful when and where you do this. You want to do this when you do not want to lose events. So, for example, your incoming orders, which you want to process because people want to buy your stuff, you don't want to lose them, so use a buffer here. Or you can drop. If the subscriber can't keep up, just drop everything that happens after that. That's something you could do, for example, with UI events. If the user is just clicking like wild, and your application can't keep up, just ignore everything the user does after a certain point until you get until you're caught up. Or you can do the opposite. You can drop everything that's waiting to process and only process the very latest things. And that's, for example, a good thing to do if you work with live data, streaming video, or something like that. If you can't keep up at that point, just ignore everything that happened before that and start at the very latest point. So back pressure works best if your whole chain supports it, from the points where you process things, where you do your side effects, and the points where you produce your data. If at some point if the whole chain supports back pressure, then the whole chain will flow at a rate that it can handle. While if you have buffers in between, then, well, you can run out of memory, for example. So as long as you use the standard reactive operators, that will be usually fine and dandy, because they all support back pressure. Unless, for example, there's a reason they don't. Well, something that produces a tick every 100 milliseconds, it's not going to support back pressure from itself. It's just going to tick every 100 milliseconds, and you need to handle overflow. As long as you keep using reactive streams publishers, then you'll also be fine, because they all support back pressure. But the thing you will run into is when you create your own observables. You have to be very careful then. So how do you create these observables? Well, it depends on what your source data is. If you have Java or Scala collections, then there's a from adapter, and it will just transform your collection into an observable. If you have a synchronous API, you use generate. If you have a callback-based API, you can use from emitter. And if you have a reactive streams API, then you can use from publisher. So that's also a very easy case. So, trivial case, when you already have a fixed number of values, or when you already have a Java, already have a collection of something, just call observable from, say which collection you want to transform into an observable, and Rx will transform it into observable at the pace the subscribers can handle. More common is when you have an existing callback-based API, which you want to bring into the reactive world. So at that point, you have a from emitter constructor. What will this give? Every time a new subscriber subscribes to you, you'll get a reference to. Wait, does this work? You'll get a reference to the subscriber. You can set up your callbacks there, and whenever you get data through that callback, you can call the next event manually on your subscriber. You can also ask the emitter to call some code of your own whenever your subscriber cancels. Of course, because this is an existing callback-based API, Rx won't know what to do with back pressure. So at that point, you will have to manually say, I want to drop, I want to buffer, or I want to only process the latest events. This is a very useful API, so that's why they renamed it to a primary constructor in Rx Java 2 and in Reactor. So in Rx Java 1, it was introduced a lot later than the original methods, and that's why it has this awkward name. If you use Rx Java 2 or Reactor 3, it's called Flux Create or Flowable Create for a reason. This is your primary thing you should use whenever you have a callback-based API. Another example. Say, for example, you want to listen to a socket and you want to read bytes from this. And you only have a blocking API for this. So we have an interface, a socket from which we can read a byte, which is blocking, and we can disconnect from it. We also have a factory method, which allows you to listen to a port and get a new socket instance. If you want to bring something like this into the reactive world, then you can use the generate method. In the generate method, you can create a function that will get called every time a new subscriber wants data from you. And in that factory method, you can set up whatever you want. In this case, we open a new socket and pass that on. Because what will happen the next time your subscriber can handle data is you'll get the state which you generated here, it will get passed to you. And you also get a reference to your subscriber. So at that point, you can call the subscriber and with the data you read from your state. Obviously, this will still block if there's no data available from your socket, so you have to be careful on which thread you do this on. But usually this is the correct place to block, because it means there's no more data to process. So you just block, you can't do anything else at that point. On unsubscription, you'll get a reference to your state again, and you can do whatever you want with it. So, so in this case, we want to disconnect the socket. So you might notice that this says initial state. That's because you can also modify the state in between. For example, we can use it to build a very simple counter. In this case, a new subscriber will want data from us. We generate an initial state, which is 0. And whenever our subscriber can handle more data, we'll get our current state, we'll get a reference to our subscriber, we'll emit our current state, and then we create a new state, which is just the current state plus 1. So this will create an observable that will start at 0, then generate 1, 2, 3, 4, whatever. And that works because we generate our state here, and then every time we generate a new state, we modify the state. And this is in general how you deal with state in a reactive system, in Rx at least. So there's an operator specifically designed for this. This is called scan. And what scan does is it operates on your stream of inputs. It combines your latest input with your current state, and it will produce a new state which will feed back into itself, and it will also emit that state. So how does it look? Well, if we have an observable which emits 1, 2, 3, and 4, we scan over it starting at 0. We get our current state, which will be 0 initially, and the next input, which will be 1, and then 2 and 3, etc. Then we create a new state, which is the accumulator plus our next integer. So if you subscribe to that, it will print 0, 1, 3, 6, 4, because you just sum the integers. This is a bit of a toy example, and I like toys, so I'm going to give another toy example. What if we want to use observables to control a very simple light switch, to control light? But we have a problem. We have a light switch, but it doesn't have an on and off button. It can just listen to button presses. It will only generate an event whenever someone presses the button. It won't do anything else. That means that we ourselves have to deal with the state which says, is the button off or is the button on? In this case, we can model our state as follows. We have a variable, a field, which is a Boolean, which says the light is currently on or off. And we can have an action which we want to do next. And it can either be no action, or we can turn the light on, or we can turn the lights off. If you integrate that with scan, then you start with your stream of light switch clicks. You scan over it with your initial state, which is the light is off, and we don't do anything. This is the first thing that will happen, so effectively nothing will happen. At that point, then whenever we get a button press, we get our current state. If the light is on, then create a new state with the light off, and an action, turn the light off. Or else, we create a new state with the light on, and an action, turn the light on. Then we collect this state. Then we collect the actions from the state. So how we do that is we collect, and if there is an action we want to take, we map to the action. We send these actions to whatever handles our light switch. Obviously, this is not really pretty. I mean, this is quite a lot of code, especially when you have this in your main application loop. So we have a way to hide that. I personally prefer to do that with compose. What does compose do? Well, compose requires one function, which takes an observable of a specific type as input, and gives you an observable of another type. And it will emit the events from that second observable. So instead of writing this whole scan, in our main application loop, we can listen to the light switch clicks. We can compose to whatever function deals with this. And then we can send the output that comes from that to whatever component handles our light switch. It's also a bit of a cheat code, because you can do whatever here. It doesn't really matter what you do in this controller. You just need something with a signature which takes an observable of the type which are your inputs and returns an observable of the types which are your outputs. You can do whatever here. So if you want to do it correctly, functionally, Haskellly, whatever, you can use scan. If you want to do it with actors are really nice for dealing with state, then just send all your inputs to an actor and stream all your outputs from an actor and create and convert all the outputs from your actor, all the messages that your actor sent to a stream. Akka, for example, has an adapter for that, which will turn all the outputs from an actor into an observable. Or you can interact with a synchronous library here, whatever. If you really must, if it's 5 a.m. and you have a demo at 10 in the morning, just throw in a few vars in there. Who cares? I mean, we'll refactor it later, right? So this is a really nice way to hide this state. So I hope I've given you a few examples of problems you can run into in Reactive when you work with RX, and solutions on how to deal with those. Are there any questions? Yes.
What is the difference between the map function and the compose function? Is this sort of the same?
No, they are somewhat related. What a map does is you get an event and you get the event in the stream, you transform it into something else, and you get a stream that gives the output of that. Compose gives you the whole stream. So the type signature of map would be observable.map with a function from T to U. Instead, now we get a whole stream, and that allows us to also incorporate the history of the whole stream. If you have a map, then you don't know what happened beforehand in the stream. You only know what this event is. So that's the difference. Versus what, sorry? Yes. Yes. So the question is, what's the difference between scan and reduce? Scan is very similar to fold, and fold is a reduce with an initial state. The difference between scan and fold is that scan emits every intermediate step. So if you have a fold, if you do a fold on a stream, then you'll just get all of your inputs, it will aggregate them all, and send one single output. Scan, however, you have a stream of inputs, you get an aggregation, it will send an event. You get a new event, it will aggregate it and send out that aggregated state. So that's the difference between scan and fold. Are there any more questions? Yes?
How does it work when you have back pressure with multiple observers?
That's a very good question. Oh yeah, sorry. The question is, how does back pressure work with multiple observers? Usually what you want in reactive programming is that each subscriber gets its own instance of an observable. So, for example, if we have, let's see, if we have an observable here, with just 1, 2, 3, 4, which only generates that, then each new subscriber will get 1, 2, 3, 4 again, and it will get it at its own tempo. So that's how back pressure works. You can also create observables which share the data source. They're called hot observables. And then usually it's very hard to correctly back pressure. There usually isn't really a way. For example, if you have mouse clicks, you can buffer all the mouse clicks, but you don't want that. Mouse clicks are just something that happens, and if you aren't listening at that moment, then, well, they're gone. So usually observable that allows you to listen to mouse clicks wouldn't support back pressure. And at some point, when you translate those mouse clicks into actions for your system, then it's reasonable to say, okay, I want to register every mouse click, I want to buffer it, or I just want to forget everything when I can't keep up. Any more questions? Yes?
In your opinion, when is it good to switch over to classic imperative programming, to leave out reactive programming?
So the question is, when is the good time to switch to classic imperative programming from your reactive system? Well, that depends a lot on how experienced your team is with it and how hard the problem is to solve in the reactive system. So reactive programming as implemented by RX or Reactor is really good when you have a stream of data, when you can think of it like a stream. At some point that might break down. State, for example, is quite hard to think about in terms of a stream. So at that point might be a good point to switch to an imperative program with mutable variables. Or even better, switch to an actor system. That's a way nicer way to model it. And if you have to use mutable state, at least keep it very contained at specific locations where it makes sense to do so. And try to keep it out of the rest of your system. Any more questions? Well, okay. Well, thank you for your time.